All right, so here we go. We're going to talk about our properties.
You always video it?
It's always videoed. One college prep class and one academic class I'm posted on my website every day. So if you're ever absent, you can just go to my website, not Schoology. Go to the calendar and it will say for today's video, click here. And you click and voila. It's just like being here. And if once isn't enough, you could actually go back to last year's calendar and watch last year's videos. I know. You could do Precal 24/7 if you wanted to. All right, so here we go. We're going to talk about our properties. Here we are, properties.
Mrs. Ford,
Yeah.
is there any chance you have another pack? My math folder was...
You are a mess.
I know. I left my folder upstairs.
Okay. I think there are some extras.
Okay.
If there are, they would be. See that thing of papers over there by the sign that says okay. Bottom right is your place. So you can see if there's anything in the bottom right.
Yeah.
All right. Now, here, kids, here are the properties you are responsible for. I'm not going to do these just yet. I'm going to make a list of the properties you're responsible for. So if you want to take some notes here, maybe you would do that. You are responsible, I need to mark where the rights, you are responsible for the commutative property. The commutative property is the property that says I can do things in either order. So I'm going to put order next to this one. So that reminds you that when we talk about commutativity, we're talking about order. So some examples of it would be 3 plus 7 is the same as 7 plus 3. Or 8 times 9 is the same as 9 times 8. That's commutativity. That's the commutative property. It works for addition and it works for multiplication. The associative property has to do with grouping. How you associate things. You associate with your friends. You're grouping yourself with your friends. The associative property says that 5 plus 8 plus 7 can be handled as 5 plus 8 plus 7 or 5 plus 8 plus 7. Notice that in the associative property, the numbers are in the same order, right? The only thing that's different is how we have grouped them. Now, for multiplication, it would be the same thing. I'll use some letters this time. Notice I have A, B, C on both sides, but here I've grouped the B and C, and here I've grouped the A and B. When you do grouping, that's associative. This one, I bet you all know. What property is this?
Distributive.
That's the distributive property. You all know that one. That's the distributive property. One caution I have for you is this problem, this equation or thing, would be an example of the distributive property. It's like in reverse. You see that? This is the distributive property also. It can go both directions. The identity properties for addition, A plus 0 equals A. If you add 0, you get the identical number. For multiplication, if you multiply by 1, you get the identical number. These are called the identity properties. If you add 0 or times by 1, you get the identical number back again. The inverse properties are the properties that allow you to cancel things out. So for addition, it's like A plus the opposite of A is 0. And for multiplication, A times 1 over A is 1. If you add 7 and negative 7, you get 0. That's the additive inverse. If you multiply 6 times 1 over 6, that's 1. They cancel out. That's the multiplicative inverse. So there's a crash course in the 5 properties you are responsible for right now. There are a lot more. Flashback to geometry. Maybe you don't want to. Reflexive, symmetric, remember all that, transitive? There are more properties, but right now we're focused on these 5. All right, so with that in mind, let's look at problem 10 on our worksheet. Which property is illustrated? Now, some of these we may have already done, but let's go through them again now that we had some time to talk about all this. Okay, which property? A. That's distributive. Can everybody see it?
Yes.
That's distributive. What about B? Commutative. Now, why is it commutative? Because on the left side, it says X plus Y, but on the right side, it says Y plus X. How about C? Be careful. What's in the parentheses? On both sides, do you have different things in the parentheses? No, so it's not associative. Associative means you group different things. It's commutative because on the left side, we're doing 6 times the parentheses, and on the right side, we're doing the parentheses times 6. So what did we do? We changed the order. That's commutative. How about D?
Identity.
Identity for addition, right? That's the additive identity. The identity for addition. What about E? That's associative. For E, on one side the 4 and the 3 are in parentheses, and on the other side the 6 and the 4 are. That's associative. What about F? Multiplicative identity. You sound so smart when you say that. Multiplicative identity. How about number 3, or G, letter G? That's the multiplicative inverse. They cancel each other out. And what about H? That's distributive. Does anybody have a question about?
You say F is multiplicative
Identity. When you times by 1, fill up. When you times by 1, that's your multiplicative identity.
So what's the difference between example E and C, between commutative and associative?
E and C. Yeah. If you have the same thing in the parentheses, it can't be associative, because that's what associative does, is put different things in the parentheses. Associative says, instead of having 5 and 8 grouped, I'm going to have 8 and 7 grouped. So if you have the same things in the parentheses, you have not done associative. Look, on one side, the 6 is at the front of the problem. On the other side, it's at the back of the problem. So what did I change? The order of the problem. And when I change the order of the problem, it's commutative. Okay? All right, now we're ready for P2. Okay, so we're making this transition to P2. What does that mean? That means that you should be able tonight to finish your P1 homework if you haven't already. Also, it means that the next class we have, we're going to have a quiz. Okay? Did I tell you we have one today? Are you sure? we're gonna have one next class. If that's tomorrow, we're having one tomorrow. Over P1. So what are the things you have to know from P1? Well, you need to know your properties. If we have time at the end of the period, I'll run through a little review, but you need to know your interval notation. Remember how that works? What do the parentheses mean? Open circle, open dot on the number line. What do the brackets mean? Closed dot on the number line, so you need to know that. You need to know what to do when we simplify exponents. So what do we do if we have an x to the -5th on the top of our fraction? It goes to the bottom, right? Okay. Well, we'll talk more about those. That's what's on your quiz tomorrow. Things like interval notation, simplifying, having negative exponents, what do you do with them? And identifying your properties. And it'll be like the worksheet. I'll just give you an equation and you'll say which property that is. And it will be one of these 5. Okay? Or maybe I might give you 2 problems like that. So maybe 2 of these 5.
On the homework, there was a problem where we had to graph an infinity symbol. How do you do that? You just highlight the whole...
Yep, the whole arrow. Everything to the left or right. Whichever was negative infinity would go left, positive infinity would go right.
Okay.
Yep, we did some examples like that. So if you had the interval like this, that would mean a closed dot at 4 and then shading everything to the right. And those a lot of times will be part of a problem where you have a union and maybe something else over here. So you would have, maybe that, maybe both of those together. All right, now P2, here we go. We got some notation. All those little blanks are things you're supposed to fill in. So what do we call this line?
X.
This one right here. That's your x-axis. So that label should be x-axis. What do we call this line? That's your y-axis. What do we call this point right here? Well, its coordinates are 0, 0, but it has a name. It's called the origin. It's called the origin. All of these 4 spots are called quadrants, right? These are called the quadrants. Your job is to label them. This is Q1. This is Q2, Q3, and Q4. Notice I'm using Roman numerals because that's what mathematicians do. They use Roman numerals. Now all your blanks should be filled in except this one. It says, what's that whole thing called? Does anybody know what the whole thing is called? Anybody know? It's called the Cartesian coordinate plane. And yes, you need to know that vocabulary because that's what it is. René Descartes, named for René Descartes, one of the great mathematicians, credited with drawing pictures of equations, which is what we do on the coordinate plane. Okay, all right, let's see what comes next. Oh boy. Does anybody have any idea what you are being asked to do in this next problem? Could we plot those 2 points? Yeah. You don't necessarily have to, but just for practice to make sure everybody knows. Over or left 1 and up 3. that point A? Does that look okay to everybody? Remember how to do that? And then 7-1 over 7 up 1. There's B. Now we could certainly connect those two dots, couldn't we? But that isn't what we're doing in this problem. This problem is asking me to find the distance from A to B. Not with a ruler. I'm not going to measure this distance. I'm going to find it algebraically. Do you remember how to do that? You all know. You learned it. What? Oh, Mr. Witt says, is it Witt or Witty?
Witt.
Witt. Mr. Witt says it is a radical, a big radical. If I'm finding distance, I'm going to have a big radical. And under that radical are two parentheses squared. And inside those parentheses is that. Very good, Alex. Now, does that look familiar to you now that I've written it up there? That is called the distance formula. And if you don't already have it memorized, you need to get it memorized. Okay? Now, our 2 points are right there. So we're going to do our 2 points. Here we go. This says take your x's and subtract them. It doesn't matter which one is x2 and which one is x1. It doesn't make any difference. We're going to subtract our x's. So I'll take 7 minus -1, and I'm going to square that. Everybody see where I got the 7 and the -1? All right, now I'm going to do the same thing with my y's. 1 minus 3. Now I'm going to do my arithmetic. Here we go. What is 7 minus -1? 8. And 8 squared is 64. Plus 1 minus 3. 1 minus 3 is -2, but squared is 4. So I end up with the square root of 68. Now I'm not quite done. Do you remember what you need to do with numbers like the square root of 68? Don't say type it in your calculator. That's not what we do. What do we do with the square root of 68? We try to simplify it, reduce it. And how do we do that?
Use find numbers that go into it.
Find numbers that go into it. So my particular style is I just like to break it down like this. Not everybody does it that way, and that's okay. But somehow we have to get it broken down. So I get 2 times 34, and that's 2 times 17. So broken down, I have 2, 2, and 17. And that's what I'm taking the square root of, kids. I'm taking the square root of 2, 2, and 17. Well, don't these make 4? And the square root of 4 is 2. And the 17 does nothing, so my answer is 2 root 17. All right, we'll do B together, and then there's one more that you can do by yourself. Let's do B together. We're finding the distance between 2, 6 and -5, 1. All right, so here we go. It's a big radical. What goes under the radical? Mason, where's your packet?
My bad.
Where's your bag?
I don't like to take tests. That's not how I learn.
Okay. All right, I'm gonna trust you on that.
You can ask Mr. Miller.
Okay, I believe you. I believe you. So you, okay, all right, okay. Here we go. Step 1. We subtract our x's. So -5 minus 2 squared. Everybody okay with that?
Yep.
And then our y's, 1 minus 6 squared. Now, if you want to go the other order, you can. You can do 2 minus -5 and 6 minus 1. That's up to you. It doesn't matter which way you subtract. Oh boy, -5 minus 2. Be careful. -5, -2. That's -7. Squared is 49. 1 minus 6. -5 squared, 25. Now we're going to break it down. Or not, right? That one doesn't break down because that's it, 2 and 37, no perfect squares. All right, there's one more on the back side. Could you do that one for me, please? On your own. See what you come up with. Somebody and do it on the board there. Kelly, do you have your pink sheet?
No.
Signed? Okay. And you were late because of cleaning up the gym? And we don't know where Megan is? No, I meant, you didn't have any paper on, so you can just work it over there on that sideboard. Since you didn't have any paper on, I wanted you to practice. So you can just work it over there and compare your answers to everybody else's. What'd you come up with?
13.
Not 13, the square root of 13. Everybody get square root of 13? Okay, so we're good on distance. All right, next, then we're finding midpoint. All right, now we've got to go from topic to topic. So we're good on distance. We're going to remember how that works. But now we're going to new thing, midpoint. We have 2 points. And we are going to find the distance between them. Or no, we're going to find the midpoint, the point that's right in the middle of them. Does anybody have any idea how to do this? You've done it before. Do you remember? What? It's got, it's over something.
Over 2A?
No, but there are things over 2A. That's good, but this isn't the thing. Think about this for a second. We want to find the middle x value and the middle y value. Okay? So pretend you're taking a test and you got an 80 on test 1 and you got 100 on test 2. So like your 2 points are 80 and 100. I'm giving you a grade, I need the middle of that. How would I find the middle grade for you? I add them and divide by 2. because the middle value is like the average, right? I want the average of these 2 points. I want the middle value. So I'm going to take my x's, add them and divide by 2, and I'm going to take my y's, add them and divide by 2. So my average point, my midpoint, my middle point, will be -1 plus 6 divided by 2. Those are my x's. I am averaging them. And my y's, 2 plus 4 over 2. I'm averaging them. I average my x's, I average my y's, and that gives me my average point, my middle point. So the answer to the question would be 5/2 and 3. Everybody see how I got 5/2 and 3? Now I prefer fractions. Fractions are my friends. But if you'd rather have decimals and write 2.5, that's fine. Try the next one on your own. You're finding the middle value, the midpoint. So average your x's, average your y's. Here's what I got. What did you get? Same thing? Everybody okay with midpoint? All right, good news. Number 4. These are circles. Now, I found out from the other class that you guys, some of you did circles and some of you didn't, depending on the teacher that you had. So, we have a little bit of catching up to do for those of you that have never seen a circle before. Circles are different than lines, for example, because lines look like y equals mx plus b. You've all done that before. That's what a line looks like. So like y equals 2x minus 7. Notice nothing is squared in there, right? So you'll recognize circles when you see them because they're going to have an x squared and a y squared. Now we're going to learn later in the year other things have those too, but right now, if you see an x squared and a y squared, you're going to think circle every time. Circles, y'all know what they look like. They have a center and they have a radius. So, for this, I'm going to do the second one first because it's actually easier. The center of this guy is 2, -3, and the radius is the square root of 15. Now, look at the equation and tell me, where did I get my center? Where did the center come from? It's the opposite of the numbers that are in the parentheses. So if I had a different circle that looks like this, the center would be at -5, +1. Every time, it doesn't get tricky. That's it, that's how it works every time. Now look at my radius, back to the sheet problem here. Look at my radius. I got the square root of 15. Where did that come from? The square root of whatever's over there. So for this one, which isn't on your sheet, I made this one up, the radius would be, no, it'd be 4, because we take the square root. So the square root of 16 is 4. So this one would have a center at negative 5, 1 and a radius of 4. This one has a center at 2, negative 3 and a radius of root 15. Now what about problem 1? This one's a little tricky. There aren't any numbers here, like there were here. So where do you think the center of that guy is, since there aren't any numbers there? 0, 0. If you said the origin, you are right. The center is at 0, 0. There's no number attached. So the center just stays at the origin. What's the radius? 4. Perfect. Now, if that makes sense to you, you should be able to do problem 5 without too much issue. Because problem 5 is the backwards of that. I'm telling you the center is at 1, 4, and the radius is 6. You need to write an equation that looks like this one. Can you do that? What's it going to look like? X minus 1, very good, squared, don't forget the square, plus y minus 4, very good, squared, equals 36. Perfect. Perfect. Do B. 5B. Finn, you got a thought on 5B?
Yeah.
What's your thought?
X plus 3 squared plus y minus 2 squared.
What do you think about Finn's idea? Is he on target, or do we need to correct something? Everybody okay with that? But this is pre-calculus. Things have to be harder than that. Look at problem C. Problem C is asking you to write the equation of a circle. Isn't that what Finn just did? Didn't Finn just write the equation of a circle? He did a great job. But question C doesn't give me what I need. What did Finn need to write this equation? He needed to know what the center was, so he could fill in these. And he needed to know what the radius is, so he could fill in this. In question C, all I told you was that the diameter has endpoints at 3, 7. Now you have to remember what the diameter is. Remember what the diameter of a circle is? The chord that goes to the center. Okay, there it is. Now you need to write the equation of the circle from that. Any ideas?
You have to do the midpoint.
Oh, why would I do the midpoint?
Because you have to find the y.
Because the midpoint will be the center. And do I need the center to write my equation? Absolutely. All right, so let's review. How do we do midpoint?
X1 minus X2.
Add them, average, add, right? So we're going to add them, negative 1 plus 3 divided by 2. I got 1. What's negative 1 plus 3? 2 divided by 2, 1. 5 plus 7, 12 divided by 2, 6. My center is at 1, 6. Would you agree?
Yeah.
So remember, you're writing an equation. So x minus 1 squared plus y minus 6 squared. We're almost done. The only thing we don't know is what it equals. Here's my center. Now, in order to fill in this blank, what do I need to know? The radius. This would be a radius. Would you agree with me? I don't know what that is. So what am I going to have to do? Distance formula to find the radius. So here we go. Distance formula, remember, is a big radical. How does that work? X minus x plus y minus y. And you square those. One minus 3. -2 squared, 4. 6 minus 7 squared, 1. Did you get root 5 as your radius? Shoot, I erased my examples over there. But remember, you don't write the radius here. When the radius, think of Finn's problem, when the radius was 10, what number did he put here? 100. We got to square the x's, square the y's, and we square the radius also. So what happens when you take root 5 and squaring? These cancel, right? And you just get 5. When you square a square root, the root disappears. Wow, that was a big problem. Anybody have a question about it? A step that we did that you're not sure about? One more thing on this page, I said absolute values. What do you know about absolute value? It's always positive. Now, here's the thing. When you have a problem like A, don't take the absolute value till you've worked it out on the inside. Work out the inside, and then take the absolute value. So what do we get on the inside here when we add -3 plus 2? We get -1. Now take the absolute value, so the answer is 1. We don't take the absolute value of the individual numbers, okay? B is a little trickier. Work it out first. What's 4 minus 7? -3. But the absolute value will be 3. Work it out. 4. And the absolute value is 4. So the answer to the problem is -1. Some of us are looking kind of zoned out. How much time is left? You've been watching the clock. 4 minutes? Good, let's see if we can get this done. What's C? Be very careful. Do those negatives cancel? No, no. They don't cancel because the absolute value takes care of that one, right? That's just going to be 5. What's this one? 5. What's the answer to the problem? 0. You can't cancel these negatives because that one disappears because of the absolute value. All right, here we go. How about that one? That is is 7 plus 7 or 14. Now, let's quickly do, we have to 11 till 5? All right, let me quickly give you a couple of examples of potential quiz questions. Tomorrow we are having a quiz, okay? And the quiz will have a question on it that says something like this. Simplify. 2x to the 5th, y to the negative 3rd over 3x to the 10th. I don't even need it. All right, so we're gonna simplify that. So this guy comes down to the bottom. So I have 2x to the 5th over 3x to the 10th y cubed. You aren't done though, because you're not supposed to have two x's in the problem. You're supposed to put them together. So I have x to the 5th over x to the 10th. So 2 over 3x to the 5th y cubed would be the answer, because 5 of these cancel into 5 of these and leave you with an extra 5 down there. Right? All right, another quiz question. Hang on, this is good. You want to get these quiz questions. Which property is this? Which property is that? Commutative. Good for you. Don't let the parentheses trip you up. If the order has changed, it's commutative. All right, one more. What does this look like on the number line? If I were going to draw that on the number line, what would that look like? Closed circle at 3, open circle at 4, shaded in between. Correct? All right, you can go. People worse. Are you chewing gum? No. All right. Tomorrow I need you to bring me a full-size box of Kleenex non-generic. I don't do Meyer brand. I want Kleenex or cups. Full size. So this is a full-size box.
Okay, sorry.
Yep. I'm gonna mark that down. You get a detention if you forget it.
Okay.
I do not have a book you can buy, but that's okay. And I may have access to one. I gotta do some checking and see.
I was gonna bring you a paper, which she gives me today, so can I show you at the end of the day?
Just wait till tomorrow. It's really
What up, Marty?
for both of us, but that's.
Good, you have free cover now?
Yeah.
So, I don't know what page you have.
Yeah, you might have a quiz.
Are you sure?
We didn't have a quiz.
Okay, all right. I'll
I
let
think
you
we
know
actually
if
had
I
like
can
us
use
three
one.
and Alexa.
Mrs. Ford, what lunch?
That's it.
Minute.
Perfect.
We have the minute.
Are we filming class today?